So today's lesson, we're going to be going from the standard form, moving over to the factored form. Okay, so we've completed similar lessons where we're building the factored form, we're analyzing the standard form, and so forth. But again, now we're just kind of officially just making it from this standard form, getting it to the factored form. So in the last few lessons, we've had the equation already in factored form. We analyzed properties like which way to open the vertex, the zeros. We went through, figured out how to find the zeros quickly without graphing it, and then we answered other various questions to describe the properties of the graph. Next lesson on factored form, we built the equation. So we were given some clues about maybe the graph, and then we had to actually build the equation. Okay, and then there were some word problems. Today's lesson, will feel a little like a review of I've seen this before. Why are we doing this again? But it's a little bit different. But it's just kind of taking everything that you've picked up now over all the cycles and applying it to converting from standard to factored now. Okay, so again, we built this. We looked at the properties of it, but we didn't actually go from standard to factored form. So we're going to do that today. I'm just going to make a list here of all the tools that you've picked up when it comes to factoring. Over the last few cycles. So step 1, always look for the greatest common factor. Okay. Step 2, remember if it's a simple trinomial, there's that trick that you can use. You make your sum and product table, and then boom, you have your two factors. You can write your factors out. Okay. If it is a complex trinomial, so there is a number in front here, don't use that trick in part 2. You're going to have to use the product sum, and then you have to do the decomposition method where you factor by grouping. Okay. Other things that you've picked up though along the way, there's some other tricks that you can use. If you could see that you have a perfect square trinomial, you know the factors will look like this. Okay, so that middle term here, if it's positive, then it's plus. If it's negative here, it's negative in the factors. All right, and then there's the difference of squares, or remember if these are both perfect squares, then you can quickly write your factors like that. So again, throw everything you can that you've picked up today. So again, it's like a factoring lesson again, but understand that you are changing a standard form equation into a factored form. Okay, so for the first example here, you are analyzing this quadratic, and I want you to express it in factored form. So right now you should be able to identify that it's in standard form. Okay, so step 1, you should always look for the greatest common factor. Okay, so again, as soon as one of them is 1, you know that there's just a 1 that could be divided out. Just double check the letters. Is there a letter you can divide out? No. Okay, so greatest common factor, just 1. Okay, so there's nothing to divide out. Okay, go to the next step. So again, if you're at the point where you can guess and check, so just you're thinking right now, what multiplies to make this 1? Okay, because again, we know it's a simple trinomial. What adds to make this 1? So you can brainstorm this in your head. What multiplies to make 35 but would add to 12? So if you could think of the factors really quickly in your head, you don't have to build this table here. Okay, so this table is not necessary, but again, if you're still having trouble with this stuff, yes, I recommend that you do that. So what adds? So I'm going to write add and multiply instead of writing product and sum. So add, you can do either or though. So you're adding to 12. You're multiplying to 35. So again, we're going to start with the multiplication here. What numbers multiply to make 35? So you have 1 and 35. Okay, you have 5 and 7. Okay, and then right away, so you're like, okay, 1 and 35, you can't multiply or add or subtract those to make 12. So this is definitely a no. Okay, but then these two, yes, you can add those to make 12. So again, this is a simple trinomial, right? It's a equals 1. So from here, you don't have to do the decomposition method. You're just going to write out the factors. So again, to get full marks, because you're taking an equation and factoring it and changing it to factor form, you have to write the y equals. So that's the new thing. Before, you never had this y equals. You would just write the factors. Okay, so you have to write y equals, and then you go x plus 5, x plus 7. Okay, and that's it. Okay, so now you have gone from standard form to factored form, and then you're set. Okay, all right, so move on to the next one. So again, this, just because you are seeing factoring again, I don't know, this is maybe the 4th lesson where you're seeing factoring. Hopefully you are at the point where you can kind of try and experiment with guess and check. So in your head, what number multiplies to 35? but what two numbers can also add to that middle term, okay? So, and again, after you've taken out the greatest common factor. So try to use the guess and check method right now. So I'll do a few more, and then maybe I can do these examples again using guess and check, okay? So for now, I'll just kind of do it the way we were always doing it. All right, greatest common factor. So this is a 1, this has a -1 and a 12, so the only thing I can divide out of all of these is a 1. All right, so then let's go to what adds to the middle one and what multiplies. So again, remember, always go multiply both of these together. Okay, so you get 12, -12. All right, so again, 1 and 12, you can't add or subtract those and make 1, so that's no. 2 and 6, I can't add or subtract those to make 1. 3 and 4, well, those work, okay? So since I have a -12, that means one of these numbers has to be negative. So let's say I'll make this one negative, and we'll make that one positive, and then vice versa. Okay, and then the trick here is if you know it's negative, the bigger number of the pair should be negative. Okay, so if we know it's 3 plus -4 is going to add to -1. So these are the two numbers. Okay, so again, write this equation in factored form, write the y equals. Okay, and there are your two factors. And again, if you, on the side somewhere, FOIL this back out, you should go back to the original, and that's how you check that you do have the right factors, okay? And I know a lot of you have been handing in checkpoints where you're checking it, so that's really good, okay? All right, let's go to the next one. So same thing, just get in the habit of always going, oh, is there a greatest common factor? Okay, don't forget that step because it can lead to a lot of frustration here if you miss this step here. Okay, so again, I see a 3, a 24, and a 45. So if, when in doubt, if you can't think of a number that works, just try the smallest one and see if that might work, okay? So if I divide a 3 out of all of these, it should work, yeah, okay? And they don't all have an x, so only a 3 will come out. So then let's go and divide the 3 out, right? And then write this as y equals, greatest common factors there. Now let's divide everything out, x squared, 8x, and then 15. Okay, so again, a lot of people, they do that one step. They're like, I factored, I did something, I'm going to stop and move on to the next question. Okay, but don't do that. There is this part here left in the bracket that yes, you can factor. Okay, so here, I'll use a different color. So again, you have the middle term, 8. You have to add to positive 8, and then you have to multiply to 1 times 15 is 15. Okay, so these are the conditions. They have to follow both of these conditions so you need the factors. Okay, so I'm thinking here 1 times 15. No, that can't add or subtract to 8. 3 times 5, yes, that one works, right? Because if I add those will be the factors. All right, so now, because you took the 3 out, so now what's left, see how it's just a 1 here? Now the stuff inside of here is a simple trinomial. So then you don't have to do, the decomposition method now. So you can just go right to here and write in x plus 3, x plus 5. Okay, so, and then from there, that's like 3 marks. I guess there's 4 marks here now if I'm marking these today, because I also want to see the y equals. Make sure that's there. That's the new part. All right, but you took your GCF out and then you found your 2 factors. So that's 4 marks right there. Okay, so make sure you remember everything. All right, so keep going along here. Again, step 1, GCF. Look for that first. Okay, and you're thinking, so right away, if one of them's 1, like this one, okay, that's the only number that works here. So, all right, so I don't need to do this first step here of dividing out a common factor. I'm just going to go right to so I have a simple trinomial here. I need to add to 6. I need to multiply to 9. Okay, so 1 and 9, nope, but 3 and 3. So hopefully if you guys are already trying to brainstorm here, you thought of those 2 numbers right away. Okay, so then from there, write the factors out. Y equals x plus 3, x plus 3. And then you always want to clean it up. Just if you got the same factors like that, just write it like this, squared. Okay, so I did that by going through and do the product sum table, but again, if you are using all of your tools here, okay, hopefully you saw that maybe this is a perfect square trinomial, because if you're looking here and you're like, okay, if I square root that one, okay, they're both perfect squares in the middle. So if I square rooted, I would have had an x here, and if I square root this, I have not a 3. So, and then the rule is for the middle, if I take these two and multiply by 2, I'll get this number. So we knew that this was a perfect square trinomial, so you could have gone from here right to your answer as well. Okay, all right. Again, if just one method works for you, that's fine too, okay? But just I always want you to have a lot of different ways to do things more efficiently and so forth. All right, here's the next one. So again, first step, always look for greatest common factor. Okay, so seeing a 3 works for both, no letters, so let's divide that out. And you get to here. All right, and then again, always check to see if you can factor in here, and some of you might go, oh, well, the middle one's missing, so I know I have to add to 0, and then I have to multiply to 9, or negative 9, or some of you maybe would have remembered the difference of squares method, which is this one here. Okay, so you're like, oh, there's a difference of squares there, so you know, if you square root this one and square root that one, they're both perfect squares, and it has to be a difference in the middle. So then you know the trick is this will become minus 3, and that'll become plus 3, like that. Okay. But again, if you use the product sum table, you would have noticed, oh, 1 times 9 doesn't work. 3 times 3 can be tweaked to make 0, because one of them has to be negative. Okay, and so one's always plus, one's always minus when it's a difference of squares. Okay, then we go to the last one. Same thing, step 1, greatest common factor. Just do it every time so that you just aren't struggling with stuff here. Okay, so I'm looking, and a 3, 11, and 6, nothing works here, right? 11's a prime, so only a 1 will work. All right, so the next step here is then I have to do the product sum table. So what adds to the middle one? What multiplies the 2 outside ones? Okay, so the middle one's 11, and then don't forget what multiplies to the 2 outside ones. That's 18 for the product that you have to find. Okay, so 1 and 18, nope, nothing works to make 11. 2 and 9, oh yeah, that one works, right? That will multiply to 18, and they will add to 11. Okay, so again, this is not a simple trinomial, right? It has a 3 in the front, so don't do what you've been doing here with the other ones where you go from the table and then you just write the factors, okay? You have to remember, oh, I have to use the decomposition. This is the long one. So what you're going to do is you're going to write the 3x squared. You're going to break and decompose the middle term with these 2 numbers that you found here. So you have 2x, okay, 9x, so plus 6. So again, hopefully you're finding that this lesson is a nice way to look at these again if you weren't doing as well. So this is another opportunity to try these again, practice some more, and then, just be better after this, okay? All right, so from there, remember it's decomposition. So I'm going to now see how there's 4 of them. So now I'm going to factor by grouping. So I'm going to factor in pairs here. So if I'm going to do that, I need to divide out the same value in the first pair. Okay, so I'm looking here, and 3 and 2, there's nothing that works, just a 1. But they both have an x that you can divide out. All right, and then here's this one here. You have a 9 and a 6, so you can get, a 3 out of both of those guys. And then if you try a letter, this one doesn't have the second one doesn't have a letter, so it won't work, okay? All right, so from there, let's clean this up. All right, so for the first pair, I'm going to write the greatest common factor, which was x. And then I'm going to divide out the x here, and that leaves me with 3x. This one leaves me just with a 2. Okay, the next one I'm going to divide out a positive 3, leaving me a 3x plus 2 as well. All right, and then I know you probably haven't seen these in a while, so it's good to review it. So now take these two factors out and then write what's left. So the x plus 3 is left. So from here, this is what you're doing today. You're just kind of going through and doing a lot of factoring. But today, the new thing is that you have to write y equals. Okay, we never did that before. So I'm going to go over these questions again here now, just by trying to show you kind of what I do when I do guess and check. With these methods too, with these questions too, you could have used the area model. So again, the area model still requires you to build your, the product sum table here, and then you put the numbers into a box, and then you factor out of the box to get to these factors. Okay, so again, you can still use that method here as well. But I know some of you are ready to, you picked up all these tricks and so forth. So some of you are ready to get to the guess and check, which can, if you get a hang of it, could require, it takes a lot less time if you can think of all those factors in your head, and then you don't have to do as much writing as well. Okay. All right. So let's try them out here. So again, you're checking to see if there is a greatest common factor. Do that step still. So greatest common factor here, there's nothing that works here. Okay, so now what I'm doing here, I'm going to be writing stuff, but this is what I'm doing in my head. So I know that there's no greatest common factor. I know it's a simple trinomial. Okay, so it's a simple trinomial because a is equal to 1. Okay, and so from there, in my head, I'm thinking, okay, I need to add to this one, I need to multiply to this one. So brainstorm really quick, what two numbers multiply to 35 that would make 12? So you don't have to sit there and write all the different ones out. So hopefully right away you think of 5 and 7. Okay, if I multiply those, I'll make 35. If I add those, I'll make 12. So right away, you just go right to your answer instead of writing that whole product sum table. You're just doing more things in your head. Here's the next one. So again, I'm looking for a GCF. All right, so nothing works here. I'm noticing that it is a simple trinomial, again, in my head. So now in your brain right now, you're thinking, okay, what multiplies to negative 12 but adds to make negative 1? Okay, all right. So again, if you want to start your brainstorming off, you know that it should always kind of have this form if it's a simple trinomial. So, because right now we have x times x is the first term, right? So that means x times x has to be here to make the x squared. All right, we just need to figure out what the other two numbers are. So I know 6 and 2 make 12. I know 4 and 3 make 12. 1 and 12 make 12. So you're thinking of those really quick in your head, but then you're like 4 and 3. 4 and 3 are the ones that could be tweaked to make 1, okay? But we need a negative 12 and a negative 1. So if you need a negative 12, one of these has to be negative. The other one has to be positive. So you're trying to figure out. So here you can guess and check, like throw it in. So you can like throw it in here, I guess, like this. And you go, okay, so that's the one possibility. But if I multiply them, I'll get negative 12. But when I add these two, I won't get negative 1. I have the signs the wrong way. So then you just change the signs and go, oh, this one has to be negative, this one has to be positive. And then again, double check in your head, x squared, when I take positive 3 and negative 4, that will make me negative 1. Okay, and then these two, when I multiply, makes it negative 12. Okay, so again, it's almost like you kind of throw them in, you adjust the signs, and then you get to where you need to as well. So if you can get quick with these, you don't have to sit there and you don't have to build the product sum table and so forth, okay? All right, try the next one. So again, the GCF step is still the same. I know I have to take out a 3. Hopefully with the taking out the greatest common factor, again, if you want to just get quick, you could just take it out, and then in your head, just divide a 3 out of this one. Oh, that's x squared. Okay, divide a 3 out of this one. Oh, that's 8x. Okay, divide a 3 out of this one. Oh yeah, that's 15. And so that way you don't have to write in the dividing step as well. Okay, but again, it's only if you're ready to do this. All right, and then from there, I'm seeing that this is a simple trinomial inside of here. So again, that means I know my factors have to look like this. okay? And then now I'm trying to think of the two numbers that would multiply to 15 but add to 8. Okay, so 1 and 15, 3 and 5. Oh, 3 and 5 will work. And look, they're both positive. So I know, oh, both of them are positive here, like that. Okay, so if I take these two, I'll multiply to make positive 15. If I add these two, I'll make positive 8. Okay, so again, just another way to try. All right, so next one, greatest common factor, 1. Okay, so now in your head really quick, while you're brainstorming here, what two numbers will work here to make 9, multiply to 9, but add to 6, okay? Or again, if you wanted to use that, you know, it's perfect square trinomial, you can do this as well. But, okay, you can just kind of brainstorm in your head. Oh yeah, I know 3 times 3 will make 9, but 3 plus 3 might make 6. So here is my factored form equation. All right, keep going here. GCF, 3. So again, just take the 3 out without, you know, putting a 3 here. Divide this by 3. Divide this by 3. Get to here. And here, you should just be able to recognize it's a difference of squares. So that means that the answer should be where 1 is a plus and 1's a minus. And then you're trying to think, what's the two numbers? Well, square root 9. And you get to there. All right, so the last one is the trickiest one, okay? So again, there's no greatest common factor here. We know that it is a complex trinomial, okay? So we can't use the tricks that we were using up here, but you could still guess and check this. Okay, so now that it's a complex trinomial, you're not just gonna write x and x in here. You're gonna think of, okay, what two numbers multiply to make 3? Okay, so you know one of them has to be 3, one of them has to be x. So the first numbers have to be 3x and x, okay? All right, so now we have to try to figure out the last number, 6. Okay, we have to multiply to make 6. So again, if we're guessing and checking, I could kind of just throw some numbers in. So like 1 times 6 will make 6, okay? But when I put them in, will this work and add to 11? So you go 3x times x is 3x squared, yep. This times this is 18. This times this is 1. So you have an 18 and a 1 now, okay? Those will not tweak to make 11. So this is not going to work, okay? Just write no. Okay, so let's try it again. We know the first one has to be x and 3x. All right, what else makes 6? Well, the way we put it, we could have tried it this way, where we put the 6 here and the 1 there. Okay, so 3 times, that makes 3x squared, that makes 3, and then this makes 6, but again, same thing, it doesn't make the 11, so this is a no. Okay, so we've tried this 1 times 6, so the other option is to try 2 and 3. Okay, so 2 and 3 will multiply to make 6. Okay, so if we go through here, this times this makes 3x squared, this times this makes 9x, this times this makes 2x. Okay, so now we got the numbers in the right way. We need to make a positive 6, so then now we just kind of figure out our signs that we have to put in. So you just put something in, double check it using FOIL, and then yes, you know that this is the right answer here. Okay, so again, if you FOIL it out, that makes 9, that makes 2, and then that makes positive 6, like that. Okay, you end up like double checking it and it all works, so then you found your factors here. So again, it's just another way to go about factoring instead of writing all the product sum tables and so forth. But again, I know a lot of you like learning it just one way. You don't want to pick up all these extra ways, so that's fine. But I know a lot of you want to just do things faster. So again, try to use the guess and check today when you're going through practicing the questions to see if you can kind of get a faster method, okay, than doing all of this stuff. So, but if you're finding that, you know, you get stuck, you can't figure out by guessing, then yeah, you can fall back on decomposition method here. Okay, all right, so I just wanted to show the guess and check to see if some of you can pick that up. I'm going to show you the next type of question here for today, where you have the factored form, or you try to get to factor form, and then you try to find information about this form here, like all the graph properties, okay? So now that you've warmed up with how to factor again, just in case we haven't been doing it recently too much. So from there, can you get it factored? So step A, can you get it in the factored form? And then from there, find all the things like zero, axis symmetry, the vertex, the max min, and so forth that you did last day. Okay, so just the same stuff as before, just the first initial step is different here. Okay, so we have again, you should recognize this as the standard form. This is the standard form. You need to get it to factored form. Okay, so that means you have to kick in your factoring tools. So again, you can use the box at the very top if that helps you. All right, again, I want you to try the guess and check method, but again, whatever works is fine. So again, though, the step one, there's a greatest common factor though, okay? So let's divide that out. 2, so I'm going to divide a 2 here, and a 2 here. So when we get that, we're going to factor out the 2, and then the 2's gone, so that leaves an x squared for the first term. This one leaves a negative 2x, and the last one leaves a negative 8. Okay, so again, we've partially factored it. We want to factor it all the way. All right, so from here, again, use the guess and check method, but here's the product sum if you need it, okay? Okay, for the people that are guessing and checking, I'm thinking right now in our head without writing this out, what numbers multiply to make 8, but what could be tweaked to make 2, okay? And then from there, figure out what sign goes where. All right, so again, you know, because this is a simple trinomial, you should have factors that look like this. We need to figure out what those numbers are. So 1 and 8, I can't tweak those to make 2. 2 and 4, yes, those work. Okay, so now you're thinking I have to make a negative 2, so the bigger number always gets the negative if that's the condition, okay? So again, if you can't remember, just write them both ways, and you'll find that, oh yeah, this one won't add to negative 2, only this one will. Okay, all right, so we have our two numbers. Let's write them in. So it's positive 2 and the negative 4. All right, there is our factored form for this relationship. It's standard form here, factored form here. Okay, so from there, everything else is review. All right, so if I ask you for zeros, that is also me saying I want the x-intercepts. So again, if we were to graph this, you know, it was those points that were right along the x-axis, but you guys have learned the trick that, oh, when you see it like this, just pop out the opposite. Okay, so this is 4 and this is negative 2. All right, so if I asked you for x-intercepts, then I would, you know, want you to write out the, you know, the coordinates like this. Okay, but if I say zeros, it's okay to just write x equals negative 2, x equals 4. Okay, so now we know that this quadratic opens up because it's a positive a. So if we just make a rough sketch of this, we know that, you know, one of the intercepts is at negative 2, the other one's at 4, and we know it opens up. Okay, so now I want the equation for the axis of symmetry. So remember that goes right through the middle here. So again, how do you find that? Remember, it's halfway between your zeros. So you're going to take your zeros that you just found, add them together, and then divide by 2. Okay, so that cleans up and becomes x equals 1. All right, so from there, we're going to move on to the next one. So we need the coordinates of the vertex. Okay, so this would have been positive 1. All right, and so we need the coordinates of the vertex here. So we need our x and y value, but we did find our x already from our axis of symmetry equation. So we're going to put that in. So we just need to be able to calculate y by using our original equation here. Okay, so we're going to plug in x equals 1, where the x's are. Okay, and use our BEDMAS, so exponents first. So that's 1 squared is 1, times 2 is 2, 4 times 1 is 4. Okay, and then uh, 2 minus 4 is negative 2, and negative 16 is negative 18. All right, so we have our vertex now. make sure to write it clearly here so that yeah, you're showing me that you understand what you were supposed to find in this question, not just y, but the x and y for the vertex. Okay, and then, so now, you know, this number went down to number 16. So again, if we just sketch it here, so it went, okay, it's not to scale, but it went down to 18 here. All right, we know this was 4, this was -2. Okay, axis symmetry went through 1. All right, so I want to know, is this a max or min? So we know that it is a minimum. It opens up, right? It doesn't say to actually state minimum or max, but just write it anyway. Minimum, and then how low did it actually go? Okay, it went to 18, -18. That takes us to the end of our lesson today. So the key parts here are, yes, we are covering stuff that we did before. And then we're just, yeah, just we're using it in an expression, like an actual equation, sorry. We used to write it as an expression, but now it's an equation where it's equal to y equals, and then we're factoring it out. So it's a good way to practice again, and this is the whole point of cycling this year, so that we can get better and better at these different concepts here, okay? So for next year, you just want to be able to do this really quickly and you're not slowing it down. So that's why if you manage to figure out the decomposition method, you picked up the new simple trinomial trick, you know, the perfect square trinomials or the difference of squares, you can try to do guess and check today for something different to do, okay? But otherwise, if you are still struggling with this stuff, please just keep practicing doing lots more questions here today. Okay, so practice and then try the checkpoint.